So what we're going to be looking at is how do you carry the polygon back onto itself, either through reflection or rotation. So by spinning it or by just flipping it over. In this case, we're looking at, and now we can have more than one answer as our answer in this case. But here we're looking at this pentagon. It has 5 sides. Now, if you were to go all the way around, we know that would be 360 degrees. And if it's a regular polygon like this, that means all the sides and all the angles are exactly the same. So I should be able to spin it less than 360 and get that same image. So how far do we spin it? Well, 360 divided by 5 sides would tell me that I have to go about 72. So 360 divided by 5 is 72. So if I rotated it 72, I should be able to get the same pentagon. And that's what they show me here. If I take 360 divided by 5, 72 degrees would carry it onto itself. Now here we have a square, and we're looking at how can I, again, carry it onto itself. Any rotation that you want it to carry it onto itself would have to be a rotation or a spinning of about 90, 180, 270, 360. Any of those would rotate onto itself. But in this case, they're not giving those as options. All they're giving me is reflection. And so if you reflect it over t, you're going to get the same exact image again. All you did was you moved this point here up to this point there, and vice versa. So reflection across t would be the only one that would make sense. And how about here? We're going to carry this regular polygon onto itself. Reflecting across t, no way that's going to give it. It's not the same on both sides, so I can't reflect it, and that takes this third one out. There's no way we can reflect that this hexagon onto itself by going over t. All right. What about rotation? Well, this is 360 all the way around. So, and you've got 6 sides. It's a regular polygon, so 360 divided by 6 would be 60 degrees. Do we have that as an option? Well, they're giving us 45, 40, and down here they're giving us 60. So that would actually make sense. So rotation of 60 degrees clockwise would work. Okay. In this case, we've got a triangle. If we rotate it, in this case 40, well, that's not going to get us there. Because in order to get to the same place, we got to take 360 divided by 3 because it's 120 degrees. Well, if I rotate 40, that's not 120. 45 isn't 120. 90 is not 120. The only thing that makes sense is going 120 degrees. And technically, clockwise or counterclockwise would give us the exact same thing. So it doesn't make a difference if it's clockwise or counterclockwise. And I'll do this one last. This is carrying it onto itself with either rotation or reflection. Okay. In this case, reflecting across t would work, right? Because it's the same here as it is there. So reflection across t would work. But something else would work too. A rotation would also work. In this case, rotating again, either direction is going to work. But let's take a look at this. So 360 divided by 5 would give us 72. That's what we did in the first example. So if I rotate it either direction, it should work. So counterclockwise or clockwise, it doesn't really make a difference. Both of them should work to get us back into the same image. And that's that. Again, let me know if you have any